All right, so welcome back to everyone. A very warm welcome to all of you, my dear students. A very warm welcome to all of you. My name is Dr. Shankar Sir, and I am your physics educator. So, guys, in this session, what we got to do? In this session, we are going to deal with some questions of physics. Okay, so these questions I have somewhat sorted out and it will give you some concepts. So, the live student can tell me if you can see me and hear me properly. Please answer me. Can you guys see me and hear me properly, Vida? All the live students, welcome to the session, welcome to the channel. And I am expecting that if you haven't subscribed the channel yet, uh, you can please subscribe, right? So, guys, in this session, we are going to deal with some physics problems, right? And we are going to see if we are able to deal with them. Okay, so let's start with some questions. All right. So here we go with the first question of today. Come, let's do it. I'm very sure we can do. Please try to solve this question. Let's try to solve the question, my dear. All the live students, please try solving this question, my dear. So this is the question from the properties of solid. I hope we can solve this question. We have seen the concept of it. Abhishek, very good evening, my dear. Welcome to the session. Welcome to the channel. So in today's session, we are trying to do some questions of physics. Okay. So let's see if we can solve this question. Can you please try? Yeah, sure, Abhishek. Meanwhile, you can also try this question. For any such question that you are having, so you can mail me those questions also. This is my mail ID. Acha, Dev, your name is Dev. Okay, cool. So you can mail me over here, right? This is my mail ID, utilparty@me.iitr.ac.in. Okay. For all the students who are watching the video, so anytime you can mail me the question and I will revert you over your mail. Okay. Anyway, so you mail me the question, I'll see to it, and we can by that time we can start solving this question. Dev, right? So this is the question of properties of solid. Can we try it? Yeah, you can mail Dev. That's not an issue. See, I always prefer, whatever, see, questions, so in physics, question solving is not the issue. The issue as a teacher, see what is the role of teacher? What I believe that when you give me a question, I shall come up with the best way possible, or the shortest possible way. Acha, you haven't started the chapter yet. So are you aspiring for 2024? What chapters you have completed? Have you completed the fluid NLM you have completed? Okay, I'll just give you one simple question. Huh? You have completed the kinematics, right? Okay, let's try with this question. So let me do this question first of all. So see, so basically we are having a load of 50 here. This is 100. This is 100. So this will make two moments, but that will be an opposite moment. So the net effect of it will be 200 kilonewton here. Now, if this is 200, this is 250, so this is going to be 250 kilonewton, right? This is going to be also, the reaction is going to be 250 kilonewton, okay? 250 kilonewton. So what will be the stress in the first part of this body? Let's name it 1. Okay, you are preparing for 2025, so you have you have enough time, okay? But see, sometimes when we are preparing much time in our hand, that also sometimes now we feel that okay, we can delay the topic. It is not the way to delay the topic. And on the channel, there, if you follow the videos, so I have already done the motion in a straight line, units and measurement, motion in a plane, vectors, properties of solid. Okay, so you can go through them if you want. So see, simply sigma 1 is going to be 250 kilonewton, that is 250 into 10 to the power 3 divided by pi by 4. 100 is square. So this is a square cross section. So it will be 100 square. Okay, it will be 100 square. So clearly it is 25 megapascal. And now in the second section, we have this is 50 into 10 to the power 3. The next question I'm going to give you from the motion, kinematics only, don't worry. NLM you have done, Abhishek, Newton's law of motion. Forces you have done. Are you able to sort out with the forces, friction and all? Huh? So it is 50 squares. So this is going to become 20 megapascal, isn't it? 50 square. 50 square. So 50, 50. So it is going to be 20 megapascal. Okay. So what chapters you have completed till now? Can you tell me that? Okay, let's try this question. So in the last question, what is going to be the maximum stress? The maximum stress is going to be 25. Okay. Now please try this question. This is from the motion in a straight line that you have done. Very simple. Acha, acha. You can do this then. Please go for it. This is a motion in a straight line question. And units and measurement, have you done that? Okay, wonderful. Yeah, please solve. The other students also may try to solve the question here. Can we try it, please? The remaining students also may try. So see, these classes are for the live students, right? So I try to come up with questions. So any other live students is there? Yeah, this is TQ. This is like this. X is equal to T cube T minus 6. Please do. Sakshi, I didn't understand what you are trying to say. 10 class cup. I am unable to understand your context. Sakshi, can you try this question, my dear? Can you try it, Buddha? Okay, I'll do. So see, the distance transfers by a particle along the straight line in t seconds is represented by x is equal to t cube t minus 6. The acceleration of the particle will be. So for acceleration, first of all, we need to find the velocity. So velocity will be dx by dt. So it is going to be how much? 4 t cube minus 6 t cube, that is 18 t square, right? 18 t square. Now see, right away you can reach to the answer, that is D option C. In the examination, when you have the options, you can easily get to the right answer, right? Now here acceleration will be what? dv by dt. When I differentiate the acceleration twice, we'll be getting dv by dt. So when we differentiate the acceleration, what we are going to get? So we are going to get this. So this will become 12 t square minus 36t. So the answer will be D option. Understood, beta? Please give me yes or no. Yeah. Okay, so let's try one more question. Again, I'll be giving you the question for the motion in a straight line. Okay, let's try this one. I'm very sure we can do. Please do. Please try solve the question. Abhishek, Aditya, Sakshi, all the live students, you can please try the question. I'm very sure we can do. Please do. Abhishek, I don't know. Actually, sometimes what happens now, so it is an academy channel, I think you know. So basically, what happens sometimes randomly, some people come, they are not actually students. This happens, no, in online world, everything can happen. Anyway, we can solve the question. See, our part is to try from our best. Rest, we can't do anything about that. That's beyond our control. Please try to do. Harsha, this is an English channel. Okay. Though, like if you are comfortable in Hindi, so since it is a question session, I can, tell you the concept in Hindi as well. Depends upon you, right? It's an English channel basically. My name is Dr. Uma Shankar Tripathi, and I welcome you on the session. Can we try this question? Please try. Abhishek, you said that this is that you have completed the motion in a straight line. So I came up with a couple of questions of the same. Harsha, have you completed the most? What topics you have completed, Harsha? Have you completed fluid? Have you completed Newton's law? So we'll try to mix it up, right? So uh, one question of the choice of Abhishek, one question could be of your choice. एक आपकी choice से ले लेंगे, एक अभिषेक की choice से ले लेंगे. Ultimately, we are trying to practice questions as much as we can. See, in physics, question solving is very important. Unless we solve the questions, we are not going to be. Acha, Asha, you are comfortable with English only. Wonderful. This is our English channel. Okay. So, are you following the channel? So basically, my name is Dr. Shankar Sir. I am M.Tech and PhD from Indian Institute of Technology, Roorkee. I have been teaching physics from last 12 years. Okay. And on this channel, we have Nikhil Gambhir sir for chemistry and Harsh Bhatti sir for biology. So we are trying to help you guys out in your NEET preparation. Okay. So as far as the physics is concerned, yeah, Abhishek, we have completed the units and measurement topic. We have completed motion in a straight line. We have completed motion in a plane. We have completed the properties of solid, vectors, differentiation, integration. All this is completed. So I think day after tomorrow, tomorrow I'll try to give you a one short session, complete revision session of properties of solid. Afterwards, we'll start with the fluid. So what I did first three chapters of class 11 physics part 1. Then I'm trying to do the first three chapters of class 11 physics part 2. And along with it, I'll start Newton's law of motion. And then I'm about to start. I've been trying to start it, but somewhat because sessions are going very bigger. Because I want to complete the physics as soon as I can. No worries, Abhishek. See, in physics, it happens. When you see a new question, you are going to, you have to relate with the concepts. Acha, Sure, you are new to this channel. Okay. So you can watch some videos if you like. If you haven't prepared the chapter yet, so you can give it a shot. If you like find them good, if you find them that you are able to understand, then you can go ahead with those. Right? Okay. So you, Harsha, you are aspiring for 2025 or 24. If you are aspiring for 2024, okay, you don't have much time. You understand that, right? If you are aspiring for 2025, then like we can do easily if we are starting now. Okay, Abhishek. So, Harsha, have you tried this question? Shall I now solve this? See, my way of teaching in the question session is depending upon the live student. Are you getting my point? If live students, because this is a new channel, sometimes what happens, live students do not come or they do not interact. Okay, this is what happens sometimes. Like this is the second question session. In previous question session, I did a lot of questions. Okay, tricky. Yeah, yeah. You are Dave. I am really sorry. I'm really sorry. Okay, you are Dave. Okay, Harsha, are you trying this question or shall I do it? And the other live students, welcome to the session. Welcome to the channel. My name is Dr. Shankar Tripathi. I welcome you all on the channel. Oh, you are preparing for 2024. So how many chapters? Acha, acha, Abhishek. Harsha, you are a dropout. So I assume that you must have already completed the whole of the physics, right? Have you or haven't you? Have you completed the whole physics yet? Abhishek, no worries. Hello, Anuj. Welcome to the session. Yeah, yeah, Dev, I know you are preparing for 2025. For Harsha. अनुज क्या शेयर करोगे? ये मेल आईडी है, अगर आपको कोई क्वेश्चन शेयर करना है तो यू कैन मेल मी u@me.iitr.ac.in, है ना? This is my mail ID. You can share any question if you want with me. Okay, so I'll do this question now. So are you guys, have you attempted this question? Okay, I'll do. So it says the train is uniformly accelerated and passes successive kilometer stones with velocity. Class link. What is the class link? अच्छा अच्छा, लाइव को शेयर करो। हाँ हाँ भाई, बिल्कुल कर दो यार, क्या दिक्कत है? ये तो अच्छी बात। यार देखो, मैं थोड़ा सा ना टेक्नोलॉजी ज्यादा समझता नहीं हूँ भाई, बुद्धा टीचर हूँ, समझो बात को। समझ रहे हो? राइट। तो ये इतना जुगाड़ मुझे समझता नहीं है, मुझे तो बस पेन और ये समझती है कि भाई ये क्वेश्चन है, ये पेन है, एंड दिस इज दिस। ओके, सो इफ यू कैन हेल्प इन दैट वे। Harsha, we have still some time left for the exam to come, right? So if we can strategize your preparation, definitely you are going to crack it. Harsha, Telegram, we are on to it, so we'll be making one very soon. So this channel is relatively new, so we are, lining up the things. Ha, Anuj, I accept that because this channel is relatively new, and also, yeah, matlab, the reality is that I am more of a offline teacher, right? So basically, I am more of an offline teacher. So I recently have come to the online platform. Are you getting my point? So भाई ऐसा है, मतलब बच्चे कम है, बिल्कुल। अरे क्वेश्चन तो सॉल्व कर लो। Narrative that will be of a good help. Okay. So let me solve this question. See, I tell you, haha, you can send. Definitely you can send. So let me do this question. Abhishek, I have given this question. Sorry, Dave, I have given this question for you only, beta, because you said that you have prepared the chapter. Anyway, I'll do. So it says the train is uniformly accelerated and passes successive kilometer stones with velocity of 18 kilometer per hour and 36 kilometer per hour. So let's suppose this is your stone 1 and this is other stone 2. The kilometer stones are at a distance of 1 kilometer, obviously. Calculate the velocity when it passes the third kilometer stone. So this third stone must be at a distance of 1 kilometer. Now see, this is the keyword. This is the keyword. This is uniformly accelerated. Now, when it is uniformly accelerated, it means that we can use the equations of motion. What are the equations of motion? See, whenever something is under uniform acceleration, always there will be the use of the equation of motion. What are the equations of motion? V is equal to u plus at, s is equal to ut plus half at square. Harsha, you have given the answer. Okay, I'll just see. No, wrong answer. So this is ut plus half at square, and this is v square is equal to u square plus 2as. So I hope all of us are aware of these equations, no? Very useful. Very simple, isn't it? So whenever something is uniformly accelerated, like the motion under the gravity, like the projectile motion, anything like that, you can use these equations. So it says, so first of all, we have to find the velocity when it reaches, when it passes the third kilonewton stone, kilometer stone. Okay. Now it is uniformly accelerated. So what we have to find, first of all, let's find the acceleration. So now we have the speed here. Okay, so let's suppose that the motion is started at 1. Now when motion is started at 1, so I am applying the equation between 1 to 2. Okay, so which is equation I must apply? So see, we have the initial velocity, final velocity, we have the distance displacement, right? So I can apply this third equation. So at point 2, the speed becomes 36 kilometer per hour. So 36 kilometer per hour, if you want to change it to meter per second, that is also easy to do. It will become 10 meter per second right away. How so? So kilometer per hour, you need to multiply 5 by 18. Yeah, this is what happens in physics. I'll just come to it. I'll just come to it. So this is going to be 10 meter per second. So I'll write 10 square. Calculation is easing off because 18, see, in physics, what happens now, like if you operate the question with 36, 18, it is going to take you, you have to do much more calculation, right? But I can see when I see 36, 18, see, with question practice, these things come. So 36 and 18, let's change it to meter per second. So this will become 5. So see, with 5 and 10, the calculation will ease off, isn't it? So see how we are going to do. So this is going to be 10 square, 5 square plus 2 into acceleration. What is the distance? Displacement. That is 1000, right? So from here, we can have the acceleration, isn't it? From here, we can have the acceleration. So what will be the acceleration? It will be how much? So 100 minus 25, that is 75 by 2000. Okay, meter per second square. So we have the acceleration now. We have the acceleration now. Okay, now once we have the acceleration, now I can apply between 1 to 3, I can apply between 2 to 3, I can apply. So let's apply the equation of motion between 2 to 3. Now in this case, we have to find the final velocity, the velocity at 3, and the velocity at 2 will become initial velocity. So this is 10 square. Now 2 into acceleration, that is 75 by 2000. 75 by 2000, and what is the displacement? It is again 1000, isn't it? It is again 1000. Do you agree or not? Please answer me. Yeah, yeah. Now from here I can get the V. So this will become 175, isn't it? This will become 175, isn't it? See, 100, this is this 2 gone, 1000, 1000 gone. So V will become root over 175 meter per second. Are you getting my point? Isn't it? Root over 175 meter per second. Now, you tell me. See, I want to ask you this before I proceed. Now, in this question, I believe you all, if you are preparing for the NEET examination or just for your passing your 11th standard, or you must have already passed your 11th standard, we all are aware of these equations, isn't it? Aren't we aware of it? Now, I believe that when I have done this question, you must have been thinking that there is nothing in this question that you couldn't do, isn't it? So see, in physics, what I can advise you, right? So whenever you see the question, you try to converge the concept. Okay, this is a question of motion in a straight line. One way or other, equation of motion is going to be used. Now try sorting out the data, the information from the question, and then implement it. Understood? Yeah. Okay. Now do the next part yourself. See, none of you were able to do, right? So after this question, I'll give you a little tricky question. Will you try to do it? It will be from properties of solid. Okay, Dave. Right. I'll just tell you some concepts so that you can also apply. Fine. Since you haven't completed that chapter, Harsha, have you completed that chapter? And narrative, Anuj, if you are there, have you completed the properties of solid? Because like today only I have done the properties of solid on the channel, so I am kind of tempted towards giving you this question. The question of one question I have, sorted out. See how I pick up the physics question. I tell you. See, I don't only take the questions from NEET, JEE, but I also take from PG level examination. Okay, and if some of you don't have my introduction previously, so this is me. Okay, so because I see some new students here, so I feel like I must tell you about me a little bit. Okay, I hope you must have read it all. So I have done PhD in MTech from IIT Roorkee. There is one examination like NEET, that is GATE. I have qualified that quite a few times. I was in a government public service. Okay. Uh, I am having 11 years of teaching experience of these. I am an author of some research papers also, and I am a dean to engineering government engineering college. Okay. Anyway, so let's come to the next part of this question. So now what we have to find, we have to find the time, right? We have to find the time. See how we can do it. So also find the time taken for each of these two intervals of 1 kilometer. So basically it is asking you the time it took to reach from point 1 to point 2. Let it be T1. This is so extremely easy, no? The second time is T2, let's suppose. So from 1 to 2, from 1 to 2, again I can use my equation of motion. So which equation now I must use? I must use V is equal to U plus AT. Why so, sir? Because we have the final velocity, we have the initial velocity, we have the acceleration. So we can use this. So V is going to be the velocity. So at point 2, the velocity becomes 10, right? This is 5. Acceleration we got, that is 75 by 2000. So what will be the time? So it will become 5 into 2000. So this will become uh, 5 into 2000 divided by 75. Okay, and that is equal to t, and this will come in second, right? So we can have it calculated. This will be t1, right? Similarly you can find the t2, because now from 2 to 3 also you have initial and final velocity, right? Or you could apply this equation if you don't want to have the velocity, but in this you have to solve a quadratic equation. So since we have already calculated the velocity, we can use this one. So V, that is 13, so, root 175. Okay, now the initial velocity will be 10, acceleration we have, that is 75 by 2000, and this is T2. So solving this equation, you can obviously deal with this one, right? Now let's try one question. So have you guys done that question? Dave, you understood this, the concept? Harsha, have you understood the concept? And the new live students, I request you to please subscribe the channel as well if you haven't yet. Okay. Okay, now let's try this question. I'm very sure we can do. And the answer you have to give in mm. So I'll just give you the concept of this. If you, some of you haven't done this chapter yet, I'll just give you one small information. See, this is a question from the properties of solid. Okay, class 11, part 2, chapter 1. Okay, class 11, part 2, and chapter 1. Okay, so Harsha, no, not a monster question. See, in physics, questions are not monster. Don't say it yet. It is like very disheartening to me. I have been studying physics from like and still studying it. So like it's very close to my heart. Don't say. Anyway, so now come. See, I'll give you the concept. See, when you see the chapter, see, 50% of this chapter explains you the use of the Hooke's law, isn't it? Harsha, you might have done this chapter. They haven't done it yet, so I hope you can relate with me. So if the load is P, length is L, area of the body, cross-sectional area of the component is A, and Young's modulus is E. So Hooke's law gives you the formula for elongation, and that is PL upon A. This is one and only formula to find the elongation of a bar subjected to a load like this. There is no other formula, right? Here P is the force, okay? P is the force, okay? L is the length of the component, A is the area, right? And E is the modulus of elasticity, that is the Young's modulus, okay? That is the Young's modulus, okay? And I give you just one more hint to solve this question. Huh. Yeah, so this is a relatively, see, Harsha, in physics, you must enhance your concepts, no? Right? This is not just about this question. The concept that you are going to get from here will be helpful to you to solving many other questions also. Are you getting my point? Okay. Now see, this is so Harsha, you please tell me, have you seen this formula or not? PL upon E from the Hooke's law. Force you might have been using instead of P, you might have been using W, you might have been using F, but this is the formula only. Na? For E, sometimes people use this sign, gamma. I use it as E. Right? Have you seen this formula? Isn't it? The other live students? No, 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 no. It's not like that, Dave. Don't think that way. Okay? Don't think like that, beta. See, physics is all about question solving. The more you solve, like more better you will get. And also, I tell you one thing, Dave. I honestly tell you. See, I don't claim to be a If physics is this much, I know just very little of it. Are you getting my point? Okay, no one, see, if someone is claiming that I am the god of physics or something like that, so see, I live in IIT Roorkee. I live with the professors here. So I know that this is not the kind of subject nobody can claim if a question comes to anyone, right? When whether he will be or she will be able to apply the right concept at that very moment, okay? There is no guarantee to it. This is not biology. Harsh sir will beat me when I say this. This is not biology. Biology is what? Like if you, what I believe, I never have gone through the biology, right? So, like in biology, what happens if you have done proper rectification of something? This is how I see biology. If you have a good rectification of something, a question will come, you will be able to answer. There is no loophole in this. In physics, it's this kind of a subject, like you know the formula, you know the units, you know everything. After then, if you are able to solve it or not, that is always a question. This is how physics works, right? So don't think that way. So what I think that you all must have seen this formula. Have you or haven't you? Have you all seen this formula? Please answer me. Yeah. Right. Okay, now I give you one hint. So this formula will be used directly. You must have used this formula. Okay, so let me just give me a moment. Huh? I'll just do one more question before I do it. Okay, I'll just do one more question. Just a moment, huh? So that you can be easily applying this concept. In physics, using the formula correctly is also a challenge. Okay, I'll just give you one question here. Come, I'll do. Harsh sir, I hope he won't see this video. he's a he's a good friend of mine. So sometimes when I say something like this, he always tell me, sir, why you are saying so much things about biology. But this is how I feel the biology. I sometimes I like saluting the teachers who are teaching this biology and the students who are studying this biology. I don't know how you do it, right? But see, if you want to crack NEET examination, you have to do it, right? Yeah. So leave this question for a moment. I'll just come up with one more question. Just a moment, guys. Okay. Yeah. Leave this question for a moment. I'll just give you one more question. And this I'll do, that question you will do. So it says a steel bar of 40 cross 40 cross section is subjected to an axial compressive load of 200 kilonewton. Okay, very well. So 200 kilonewton compressive load is acting. So compressive means it is acting towards the surface. If the length of the bar is 2 meter, if the length of the bar is 2 meter, Young's modulus is 200 GPa, the elongation will be. So see, I have only one formula in the world to solve this question, that is PL upon A. No, no. see, it is easy when you have a good capacity of memorization, right? People, see, I am very bad at memorizing the things. Are you getting my point? Okay, so it is difficult for me. Okay, so it depends. See, whatever you have read, okay, it depends upon that. So see how I'm doing it. So see, I'm just putting everything in the formula. That is P is equal to 200 into 10 to the power 3 into L. L is 2 meters, so it becomes 2000 upon area. Area is 40 cross 40 into E. E is 200 GPa. 200 GPa, that is 200 into 10 to the power 3. Okay. So what will be the answer to it? So this is gone, this is gone, 0 gone, 0 gone, 0 gone, 0 gone. So we'll be getting 20 by 16. That is 1.25 mm. Okay. So very easy question, isn't it? Just give me a yes or no. Dave, I hope you must also have got how to use this formula. So when how I was able to use the formula directly, because everything was constant. Young's modulus was constant, load was constant, length was constant, area was constant, right? So I have used it directly. Okay. Now give me a yes or no. Do you have any issue with this question? Do you have any issue with this question? Please answer me. Yes or no? This question was easy now. Now we can try this question. Let's see. See, you can apply this formula directly when everything is constant. Now let's try this question. I'm sure if you try to do it, you will be able to. Yeah, Dave, it happens that way, right? It happens that way only. So in physics, see how I can tell you how I try approach the question. First of all, I identify the topic of the question. Like, okay, this question belongs to this particular chapter, right? This is my first step always. It might sound lame to you that, oh, sir, when we see the question right away, we'll be able to judge that this question belongs to this topic. Sometimes in physics, people mess in this also, right? Okay. Now, after I come to know or understand, okay, this question is from this topic, then I start thinking of the formulas which are used or which belongs to that chapter. And then from seeing the data or information in the question, I try to apply those formulas into the given information in the question. This is how I approach the physics. and I have seen that it works for me. Okay, let's try to attempt this question. Let's do it. Let's try to solve this question. These are the advices, Dave. Right? See, I can tell you what I tried to do. Yeah, Harsha, please try. You also try to solve this question. Let's take some time. We are in no hurry. Okay, like I don't have any. So, see, if you are able to understand one concept in a good way in this video, so that video or this session is a success for me. Are you getting my point? Please try. Let's try. We are in no hurry. You take your time. Ah, no problem there. Ah, no, no, no. So Harsha, see, my dear. Harsha, this is the formula for this question. PL upon A. Okay, PL upon A. This is the formula. Okay, so why I have solved this question? So see, did you understood this question? Tell me, please. Only using the formulas. P is the force, not pressure. P is the force. Okay. See here, I'll just explain it again. Dev, Harshad, did you understood this question when I did it? Please answer me. Okay, I believe. Yeah, this chapter is completed, and mostly tomorrow I'll be coming up with one complete revision session of this chapter. I today only have completed this. Properties of the solid. Any other live student who want to attempt this question, or shall I do it? Okay, now let me do it. See, come. I'll do. I'll do. See, my dear. No, that is not the answer. See, I just wanted to tell you the approach and how you can see attempt the question which are little twisted. Okay? No, no, it's nothing to be sorry about. Anshika, first of all, welcome to the channel, my dear. My name is Dr. Uma Shankar Tripathi. Okay, so I already have introduced myself, so I'll just. So this is my introduction, Anshika, and all the new students who are live on this channel, okay, and who have just come. So see, on this channel, what we are doing, so we are trying to help you in whichever way possible. So on this channel, I have completed four chapters of physics, okay, along with some other topics, okay. Secondly, I come up with many question session on this channel. You may find, so this is my 14th question session, okay. So basically, it depends upon, like for today, you saying that are you coming, so I'll be coming more often. And right now, what approach I am trying to follow in these sessions is that, what is the approach I'm trying to follow in these sessions? I try to come up with a little difficult question, okay, which may be helping you understanding some concept of the physics in a better way. This is how I believe physics must be learned. Are you getting my point, Anshika? Okay, so like this question, this is a little different that how you see a general question of physics. Okay, because see, to enhance the question solving ability, it is very much necessary that we attempt some good questions. Okay, so what I believe, to understand the physics properly, it is very important that you understand some concept pretty well, right? You must develop a approach of solving the questions. So these questions are of such kind, like for example, this question, this is a very good question. Now let me solve it, right? Okay. So it says a horizontal bar fixed at one end. So let's make an horizontal bar. Okay, so this is a horizontal bar. In physics, it is very important that you draw some sort of a figure. It helps you understanding the question well. So it is fixed at one end. Okay, very well. The length is 1 meter, right? And the cross section area is of 100 square. Is elastic modulus varying along its length as given by, so Young's modulus is given and it is given as a function of x. That means here in this question, the Young's modulus is not constant. The Young's modulus is not constant, but it is varying with respect to the x. Okay. An axial tensile load of 10 kilonewton is applied. Axial tensile load of 10 kilonewton is applied. The axial displacement of the free end is. So we need to find the delta. Now I tell you guys, so we must have seen only one formula to finding the deflection of a body or a component subjected to the tensile load. And what is that formula? This is FL upon A. Force into length upon area into Young's modulus. Now, in this question, what is different? What is the difference from the other question? So the difference is, in this question, the Young's modulus is not constant, but it is varying. And while you were reading this chapter, or you might read this chapter later or sometime in some point of time, you will find that you are already doing this thing, but you haven't done this thing, but similar sort of thing you are doing. Okay, like if I give you the example, all of us, while you go through this chapter, you did the self weight case. Okay, I hope if you have learned this chapter, you can relate with me. Okay, so the self weight case we have done. In the self weight case, what happens, that the load is varying. due to the self-weight. In this case, the load is not varying, but the Young's modulus is varying. Now, have my tip. Whenever in physics you find something in a variation, right away you take the strip. Whatever is varying, if something is varying, okay, along some length or along some area or along anything, whenever something is in variation, you always prepare yourself for integration. So for that you must take the strip. Okay, now we are taking a strip here. So this is strip of a very small length, let's say this is dx. Okay, now see, once you take the strip, see, in physics we have limited formulas. The only challenge is that how we are going to apply that particular formula for a given problem. Okay, like for example, in this case, the elongation, we have only one formula, FL upon A. Now see, when something is varying, what we do, we can write the same formula for the strip. Let's write it. Because see, what is the beauty of taking the strip? That as a strip, you can ignore the variation, right? You can ignore the variation. So it becomes d delta and force is F only. Now the length I'll be, because I'm writing the deflection for the strip, so I must take the length of the strip. So dx is what? This is a very small amount. Now what is area? Area is constant, let it be like this, and E is the Young's modulus. Okay, so this is also there. Now see, we have d delta is equal to F dx upon A. Okay, F dx upon A. Now see, if I am going to integrate, if we integrate this relationship, so this is the elongation of the strip. So doing the integration, you will get the deflection of the whole of the bar. So if I integrate on the left hand side, I'll be getting delta. And if I integrate on the right hand side, so whatever is constant, you can take it out from the sign of integration. And whatever is given as a function, you can place it in the integration sign. So it is 100 e to the power minus x. Okay, now further what we can do, we can take this 100 also out from the sign of integration, and we will be left with f upon 100 dx e to the power minus x. So definitely it will become e to the power x. Okay, so this deflection will become, now let us put the value. So f is given as 10 kilonewton. So this is 10 into 10 to the power 3, okay, upon 100. And what is the area? Where is the area? So it is 100 mm square. Now please take care of the units, because we are going to put the length in meters. So I must change this mm square into meter. So this will become, guys, 100. So mm square means 10 to the power minus 6, 10 to the power minus 6. And what is the integration of e to the power x? It is e to the power x only. And what shall be the limits in which I must integrate? So see, x varying from 0 to 1. So can I integrate it between 0 to 1? Yes, sir, right away. So if we integrate this between 0 to 1, so I can write like this. So this will become delta. Now we can do some cancellation. So see, 10 to the power 4, 10 to the power 4 is gone, and it will become e to the power 1 minus e to the power 0. Okay, e to the power 0. Okay, and see, I have placed, so what is the unit of this E? It is GPA. So I need to multiply 10 to the power 9 also, na, right? Into this, because it is in GPA. So I have converted the force in Newton, so which is 10 kilonewton. So 10 into 10 to the power 3. We have placed this 100, so this will be 10 to the power 9. So now what we are getting? So 10 to the power 3. Right. Okay, 10 to the power 3 will be getting. So 10 to the power minus 9 it will become. How come, sir? Because we have to place it here now. Because E is the always take care of the unit. Okay. Okay, so this will become 10 to the power 9 here. Right. So it will go 10 to the power minus 9. So from here we are getting 10 to the power minus 3. Now see, you must know e to the power. Okay, so e to the power 1 is 2.73, isn't it? It is 2.73, 2.71 nearly. E to the power 0 is 1 into 10 to the power minus 3, and the unit is meter. So what we are getting? We are getting 1.71 into 10 to the power minus 3 meter. That means we are getting 1.71 mm. Okay. So see how I have solved this question, guys. So the key point is whenever you see something is varying, something is variation, be it E, and we have done the same way. We have done the same way in the case of the weight, the self weight case also, right? In the self weight case, the load was variable. In this, the Young's modulus is variable. So anything that is varying, like if you go to my video on this channel, I have solved you, I have given you the self weight, I have given you the tapered bar also, okay? And now this question also in which the Young's modulus is varying. So remember this point of mine of physics. Whenever you see something in variation, you always take the strip and you prepare for integration. And how we can take up the integration? You take the strip, whatever formula you know, you write that formula on the strip, then you integrate the formula between the limits you are having, and definitely you are going to approach to the right answer. All right. Okay, so this is how we can solve this a very good question. So see, when you solve these kind of a good questions, definitely it is going to help you enhance your concepts of physics and it will give you confidence also, right? Okay, okay. So I hope you have enjoyed solving this question. What do you say? Have you or haven't you? Yes or no? So Harshad, this channel is completely though in English, but if some students are there online live and they want me to, explain something in Hindi, I don't mind. मैं भी यूपी का ही हूँ, उत्तर प्रदेश, समझ रहे हो? तो रहता मैं रुड़की में हूँ, लेकिन I belong from रुड़की. I belong from उत्तर प्रदेश, लखनऊ, but I live in रुड़की, Indian Institute of Technology रुड़की. Right? So जब आप इस तरीके की क्वेश्चन करोगे, when you do these kind of a question, definitely it is going to help you understanding the physics concept. Do you want to do one more question of like this? Not of the, so I'll be coming up with the fluid. See, in physics now, what happened? The beauty is that you can even solve the questions that you haven't done before. Are you getting my point? No, 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 Anshika, I'm not from South India. No, 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 no. I'm not from South India, but I keep visiting there. See, I tell you, so basically, see, I have been teaching for IIT, JEE, and NEET from last 10 years. And the usual approach of mine of teaching is I am associated with some of the offline institutes, and normally I have been called to take the lectures. So last month also I went to Calicut, Kerala, to teach some part of the physics in a very prestigious coaching institute. I can name it, right? So as I said, see, I believe that I must be very truthful and honest with the students. So I am more of an offline teacher, right? This is my first time I am teaching on any online platform, right? And I belong to Lucknow. My hometown is Lucknow, but I live in Roorkee, Uttarakhand. I live at Indian Institute of Technology, Roorkee. Okay, because I am a PhD from here. So there is some research work that is going on. So I am very much into the research also. So I write research papers also. You can find my research papers in Google Scholar. If you type my name on Google, you will find many things, right? So basically, I'm more of in the research field. I keep on going for conferences and all these things. Okay, so let us do one more question. Ready for it? Yeah. What do you say? Anshika, your hometown is Roorkee. You live in Roorkee only. Harsha, on Unacademy there are paid batches, but on Unacademy app also I teach in a special. Anshika, I live in Roorkee only, inside IIT. So if you are in Roorkee, then definitely we might have crossed ways. Which school you are studying, Anshika? Acha, acha, you live in Delhi. Okay, okay. Great, great, great. Okay, so I want you to do one question, guys. Okay, this is one of the very beautiful question I find. Again, it will enhance your concept of uh, the physics. Very small, please. Obviously, so if you live in Roorkee, definitely you must have visited the IIT. As I'm saying that we must have crossed each other quite a few times, I believe. Anyway, it was very nice to know that you belong from Roorkee. Harsha, you solved one question. I didn't get you. Sir, I solved one question that you showed in previous. This one, you solved it. So if you have solved it, that's a great thing. Have you were you able to do it correctly? See, in physics, see if you the beauty is that even you haven't gone through a chapter yet, you can solve the question, right? So now this question belongs to the fluid mechanics. Okay, actually not completely from the fluid mechanics. I'll give you some information before you solve this question, right? I'll just give you some information. This is one of the very beautiful question. Okay. Harsha, so you are saying this one? Okay, no worries. So let's start with this question. Okay, so I'll just tell you some information. So there is something named as the Bernoulli equation. Okay, there is something named as the Bernoulli equation. So this is one of the very useful equations of physics. Okay, and nearly if I say the part of the fluid, you will see that there are many questions. The steel bar 40. So you have solved this question, huh? This one. Yeah, very good. Okay. Okay, come. So see, before we attempt this question, I want to tell you something about this equation of Bernoulli. Okay. So see, I am going to give you the equation. See, you know the equation. Now see, you must try to attempt this question, right? With full of your heart, right? When you try it, definitely you will be able to do. Okay. You must try very hard. You must try with honesty, right? Okay. Now I tell you the Bernoulli equation. So how you apply the Bernoulli equation? So see, Bernoulli equation basically is the statement of energy. So you must know the first law of thermodynamics. ना क्या लेके आए थे क्या लेके जाओगे, isn't it? Yeah, that question first option. So this is what we have solved already. 1.25. Yeah, good. So this is the statement of energy only. How I say it, क्या लेके आए थे और क्या लेके जाओगे. Energy cannot be created, cannot be destroyed, but can be transformed from one form to another form. Although this is not exactly the first law, but it's a consequence of first law. The first law says for a closed system undergoes the cycle. Okay, the net heat interaction is equal to net work interaction. This is the first law of thermodynamics. The second law of thermodynamics comes with two statements. Okay, one is Kelvin Planck, one is Clausius. Okay, what is the Kelvin Planck statement? It is impossible to construct a device working in a cycle which can be 100% efficient. Okay, or the right way how Kelvin said it, it is impossible to construct a device working in a cycle which can interact with a single temperature reservoir and produce work. Clausius' statement says it is impossible to produce a device working in a cycle which can transfer the energy from the low temperature reservoir to the high temperature reservoir without any external aid. And what is the third law of thermodynamics? Anyone? Any live student? What is the third law of thermodynamics? First of all, is there any third law of thermodynamics? Just out of curiosity. Let's see how students are learning these days. What is the third law of thermodynamics? Any idea? Anyone? What is the third law of thermodynamics? And please do subscribe the channel if you haven't yet. Hmm. It is very useful, the third law. Anyone? I tell you. Normally people read it like this. So entropy of a system cannot be zero. Absolute entropy cannot become zero. Right? Although it is impossible to bring down a system to zero temperature, zero pressure condition in finite number of processes. Okay? Anyway, now let me come to the Bernoulli equation. So Bernoulli equation basically is a statement of energy, right? So like if you have to apply, I'll just show you something. So let's suppose there is a reservoir. Now on this reservoir, we are having some liquid and there is an orifice and there is an opening at the bottom of it. So let's suppose we have to find the velocity here. So this is point number one. Let's say this is point number one, okay, and this is zero, okay, and I need to apply the Bernoulli equation between 0 to 1. So see how we can do. So P naught by rho G V naught square by 2G plus Z naught. Z naught is what? It is height from the datum. So we can always assume the datum from the bottom point, and this is your Z naught, the height. Okay, is equal to P1 by rho G plus V1 square by 2G plus Z1. So this is your Bernoulli equation. So guys, we all must know the Bernoulli equation, isn't it? So if you have to apply the Bernoulli equation between 2 points, what you have to do? You can write it like this. P naught by rho G plus V naught square by 2G plus Z naught is equal to P1 by rho G plus V1 square by 2G plus Z1. Right? So this is what we know as the Bernoulli equation, right? It is the statement of energy. And wherever you are applying the Bernoulli equation, you must always apply this equation between those 2 points in which you can make maximum variables zero, right? Sometimes what we do, we apply the Bernoulli equation between the points where there are so many variables that we cannot cancel them out. Okay, like in this question, in this, statement of a problem, in this, we have applied the Bernoulli equation between 0 and 1, right? Now, at point 0, the pressure is atmospheric. At 1, the pressure is atmospheric. So, I can cancel them out. Okay, or I can make the calculation in terms of the gauge pressure, not in terms of the absolute pressure. So, these two are cancelled out. Now, at the free surface, I can take the velocity as 0 or I can neglect the part of the velocity. So there are two reasons to it. First of all, it is a free surface, so we can assume momentarily the liquid is at the stop, right? Okay, or we can assume that reservoir area is large enough so that the velocity of this point 0 is negligible comparison to v1. Okay, now this z1 is also 0, this z1 is also 0. So when we are applying the Bernoulli equation between 2 points, if you are applying between such situations where the variables can be cancelled out like this, so it will be easy to apply. Now see, this is Z naught. So I can, normally it is given as H also. So what I can do, I can place Z naught as H and the V1 square by 2G like this. So it will become V1 is equal to root 2GH. V1 will become root over 2GH, right? This is going to be your V1. So simply by applying the Bernoulli equation, we can find out the velocity at the exit of a reservoir simply using the Bernoulli equation. So see, whenever you are applying the bundle, whenever you see first of all this sort of a problem, you can apply this concept. Now I give you one more tip or advice. See, if you know the velocity here, if you know the velocity here, so then you can use other concepts of physics also. Like for example, when you are knowing the velocity of some fluid at some point, and if you are asked that you have to find the distance, let's suppose they give you some time and they ask you that in this much time what will be the distance covered by this stream. Okay, so you can simply apply your equation of motion, isn't it, if you know the acceleration, right? This is a hint for you to solve tricky questions, okay, like this one. Okay, can we please try this question? Now, please try this question. See, you have all the information, all the hints. I have even given you the formula also, right? This is your formula. Come, now let's do this question. So I'll just paste it here. Yeah, let's try it. See, take your time. We are in no hurry. Oh, So due to some reason, yeah, I have been speaking from a while and my video audio is not working. Oh my goodness. So all of you must have attempted. I have been speaking this much. So this is how when it happens, I need to learn from you guys how to do all this online things. Okay, so I'll do. So the answer is I suppose is 1 meter. Very good, Harshu. Wonderful. Now see what you have to do. So this is basically if you think, see now let me do this question. Now let us do this question using the concept that we have learned and see this is a multiple concept question. Now it says a tank open at the top with a water level of 1 meter as shown in the figure. Okay, very well. It has a hole at a height of zero point 0.5 meter. A free jet leaves horizontally from the smooth hole and the distance x where the jet strikes the floor is. So we need to find this x. Now see. Now, this is looking somewhat like a projectile motion, isn't it? The projectile motion from the height of a tower. So, see, when the jet is coming out, let's suppose it's coming out at a velocity of u, okay? At a velocity of u, and we need to find this x. So, how we can approach this question? Now, come. So, see, we have to find this x. So, can I say, so again, I have to use the equation of motion. So, s is equal to ut plus half at square. So this is our equation of motion that we very well know. Now see, this jet when it is moving, so obviously it is moving in x direction also, it is moving in y direction also. So it is basically the somewhat looking like the motion in a plane. And it is exactly the same as we do the projectile motion from some height. Okay, so now if I use the equation, this equation in x direction, okay, so do you believe that the displacement, let us suppose that this is your point 1, okay, and this is your point 2. So I am applying this motion equation from point 1 and 2 in x direction. So what will be the displacement in x direction between point 1 and 2? This is x only, isn't it? This x distance that is asked in the question, okay, and ut, okay, so u is the velocity at exit at point 1 in x direction, in x direction, okay, in x direction. And what is the acceleration in x direction, guys? So x direction acceleration is 0 because see it is falling under the gravity. So acceleration due to gravity acts always in the downward direction. Acceleration due to gravity doesn't happens to work in the x direction, right? So x is equal to ut plus half at square. So here the acceleration in x direction is 0. So now please tell me one thing. If we have the u and if we have the time, we will be able to solve this question. Is it or isn't it? Definitely yes, sir. If we have the velocity at point 1, if we have the time in which this stream reaches from point 1 to point 2, we'll be able to solve this question. Now see, between point 1 and 2, if I apply the same equation in y direction, now see, when this stream is coming out from here, it is obviously having the velocity like this. So its initial velocity in y direction at this point is obviously 0, isn't it? So in the y direction, when I apply the equation, so s is equal to again initial velocity ut plus half a t square. Now remember I am using in y direction, so let me write sy uy ay. Now what is this sy? So sy is minus zero point 0.5. So this is the sign convention I follow. From the reference, whatever vector is there, if it is in the downward, if it is moving in the downward, so if this is your reference point, okay, and from the reference, if any vector is in the downward direction, if any vector is in the downward direction, any vector is in the downward direction, we take it in negative. So this sy, it will become minus zero point 0.5, okay. And what is the velocity at point 1 in y direction? That is the initial velocity, so it is 0. Now it is half ay. So ay is what? So acceleration in y direction is minus g because acceleration due to gravity is always downward, and this will be t square. Now from here, it seems to me that t is coming out to be root over g, isn't it? Plus minus root g. So it cannot be, time cannot be minus, right? Minus root g makes no sense. So it will be root g. Okay. So time we got. Okay. Time is root g. Now what is left to be got? Sir, u is left to be got. So let us apply the Bernoulli equation between 0 to 1. And obviously, as we have seen, we're going to get what we are going to get. We are going to get v1, which we are calling u as root over 2g and h. Okay, so this is actually it is going to be the downward now. So it will be 1 by root g. So it will become 1 and minus minus cancel out, and this is going to be 1 by root g, right? Not root g, but 1 by root g, isn't it? So t will be getting as 1 by root g. Okay, I missed this thing. Now I am correcting it. So see, it is going in the denominator, obviously. Na? So it will become 1 by root g. Now see what is going to happen here. So it is root 2gh, isn't it? So v1 is equal to u is equal to root over 2g. And what is the height? So now see, if this hole is 1 meter and this is 0.5, so this height that we are seeing here is obviously 0.5 meter. It's obviously 0.5 meter. So can I write zero point 0.5 here? So this u we are getting as root over g, isn't it? So from Bernoulli equation we have got this. Now see, we can now find the x value. So u is root g, t is 1 by root g. What we are getting? We are getting 1 meter. We are getting 1 meter. So guys, in this question we use two concepts. One concept from the fluid dynamics, which is the Bernoulli equation, and one concept is the motion under constant gravity, and in that the motion in a plane that we read the projectile motion. No use of any formula, very very simple. So sometimes in physics what happens, they make a question like this in which you are required or supposed to use multiple concepts, okay, and that are not very difficult to use if you understand those concepts well, if you try to converge down the information you are having in the form of question solving. So I hope you have enjoyed this question, isn't it? Okay, so we'll solve few more questions later. बताइए. uh Are, so you were saying something. No problem, Dev, you were out. Anshika, have you got this question? Harsha, Dev, okay, this is a good question, isn't it? Right, you needed to use few concepts in this question, right? So you please subscribe the channel. Definitely you are going to get every notification, and on this channel chemistry and biology is also taking place. Okay, chemistry and biology is going. Harsha, have you solved the same way? Good question, isn't it? So when we do such kind of a question, see, so do you think that, like, or see, once you understood this question, you must be feeling that this is not that difficult. The only matter is that you apply the right approach. Abhishek, so time I usually see, I can come live any time. So you please subscribe the channel. What are your recommendations? At what time you prefer me to come to the live? You guys suggest the time in which you prefer me to come on the time. 5 बजे. Hmm, ठीक है. So I'll try to come live tomorrow 5 5 बजे. ठीक है. Sounds good. Other students, what is your recommendation? So I'll come up with, see, I'll tell you. So see, this is how we are going. So let's start with the first chapter of physics. I'll be coming up with the questions of unit and measurement tomorrow. Sounds good? What do you say? 3 बजे sounds good to me also. If 3 बजे is comfortable, 3 p.m. is comfortable to everyone, let's decide the chapter today. So I'll come up with units and measurement. We'll do previous year question and other questions, right? Live only. What do you say? Sounds good to everyone? Acha, sure, this time is good for you. All right, so 3 p.m. Harsha, is that works for you? Does that works for you? ठीक है तो 3 p.m. sorted. Dev, what is yours saying on that? So we'll do units and measurement question. I think this is the units and measurement is the first chapter. So if you have read it before, then definitely you can have a revision. And if you haven't completed the units and measurement, if you need some revision, I have done one short session of units and measurement on this channel. Right? It's I think somewhat 4.5 hour session. So units and measurement we have done every session. So I have you can find the detailed videos on this channel also. And if you want to have a quick revision, you can go for the one shot video also, right? Whichever prefers you. So let's do it from tomorrow. Okay, you come prepared of units and measurement. We'll try to do as many PYQs we can. Okay. Sounds good? Yeah? Okay. Done? Deal. Done deal. So I'll be stopping this session now then. Okay. I hope you guys have enjoyed this session. Did you or didn't you? Yeah? So I hope you will come up revising. So I'll do one thing. I have 1, 2 topics left of properties of solid also. I'll do it in the evening. I have to tell you the shear stress and the bulk modulus thing and somewhat relation between the elastic constants. So this will do. Okay, wonderful. Okay. So guys, I hope you have enjoyed the session today. So please do subscribe the channel. Please, if possible, share with your friends also so that more students can come to the live and we can grow our channel also. So with this, thank you very much. Have a good day. Thanks you for joining. And we'll see you tomorrow at 3 p.m. and we'll be solving the questions of units and measurement, mostly the previous year question. Okay. So thanks for joining. Have a good day. We'll see you in the next session.